Hey guys, today we will be discussing the question a new year resolution. In this nothing is said. In the start of the 2026, a chef made a resolution to do exercise daily. So he will be doing X push-ups every day. So on the month of January, 31 days are there. So here it is asking the number of push-ups will be in January. So it will be 31 into X. So 5 into 31 is 155 and 500 into 31 is 3100. So our answer will be C out 31 into X. Okay. So for next question we have given, you are given a string S of length n. The strings contain only lowercase letters. You can freely arrange the character S however you like. After arrangement, is it possible to make first and last character same? So we can arrange the string freely. Okay, A B C D E F G is there. So what we will do, we will just map all the things, map of char comma int, whatever will the count of the each character we will pass it, and we will just see if any character has greater than equals to 2 number of char. So if map of any character, suppose IT is greater than equals to 2, then our answer will return yes or no. Okay. So here we can see the correct answer is, we will in 10 string S, we will iterate for each of the map of IT. We will see just if the each character, whatever is the maximum character length character in the string, if it is greater than 1, then we will return yes. If it is greater than no, means all words are only single characters are there in a string and no one is double or more than double, then our answer will be no. Okay. So in this, it is one of the interesting questions. So here this chef decided to watch a movie and has just entered the theater. So here what is the question? I will explain it in short. You can read first and then go to the solution. So here, if chef is here, hey guys, and he will be sitting, there are seats in one row like from 1 to 2n plus 1. Okay, so only even odd pairs of seats are occupied, evens are empty. Okay, then we have to find that. So chef thinks the loudness, so chef thinks the loudness of an empty chair is the maximum height between the two chairs. Means if he is sitting in this middle chair, so maximum height is this between two. Okay, so what is that? Max of A comma B. So it is the height level. Okay, height level is max of A comma B. Okay, so the loudness of the seat 2 is the maximum height level of first and 3. If the maximum level of height 2 is maximum 2 or 3, maximum level 4 is 3 or 5. Okay, and so on. So to properly enjoy this movie, chef would like to choose seat with loudness is low as possible. So hype level should be less. Okay, so how we can find? So just we have to find maximum's minimum. Okay, so we can go like okay, see, this is the minimum hype. So it we will take, for now we have to minimize it. So we will take the maximum number whatever will be there. Okay, and we will see for each hype what is the maximum between them, and we will take the minimum of that. So in the code we can see, so we have taken maximum minimum equals to mn equals to int max, and we are seeing the what is the sum between their maximum. So we can see here, so for 0 we are taking 1 and 3's. Okay, for 2 we are taking 3 and 4, 3 and 5, then 5 and 7, then 7 and 9, then 11 and 12. So here the example is like, we can see 20, 2, 8, 19, 7. So for this, first a of 0 becomes 20, a of 1 becomes means a of 0, it's 0, 1, 2, 3, 4 na. So for them maximum is 20, for them maximum is 8, for this maximum is 19, for this maximum is 7, maximum is 19. So what is the minimum among them? Is 8. So our answer is 8. So same. So you can see the code, it is same as I shown you. Hey guys, we will see this question D, and this is 2 pile game. In this question we are given Alice and Bob are having a tea party in which there must be some snacks on the table which in the front of Alice and Bob. So their name is biscuit and cake, and initially X biscuit are there and Y cakes are there. So we are given 3 operations. We can eat one, they can reduce one biscuit, or either in second option they can reduce one biscuit and one cake, or they can either reduce one biscuit, increase one biscuit, or decrease one cake. Okay, so we have to find who will be the ending the biscuits after eating or after doing these operations. Who will be the ending? We have to return the name of that. So 2, 0 here ls will, and they all will play optimally, means to win. Okay, so here a and b is there. So in first operation 2, 0 is there, so ls will do 1, 0 first operation, and then Bob will also do first operation, it will complete. Second also ls will eat, then Bob will do first operation, then ls will do first operation. Similarly for that, similarly in third case 0, 1 is there, so ls will do first 1, 0 third operations, so it will decrease 1 and it will increase 1, and such that. So and here Bob, so we can see there are only one operation. We can see c minus doesn't has no value only, because in second or third case it is doing manually. So we can see only our first, only the main thing to handle is that b minus can be done in 1 or 2 by 2 operations, and b plus plus can be done in 1 or 2 operations. So we can see that, so either we can third operations, so either we can increase or decrease b minus. There is no sense of having c decreasing c, because in every case c is decreasing only. So we can see that if b is odd, then ls will win, because number of turns will be odd if b is odd. If b is even, then Bob will win, because number of turns to end that b will be odd, even, that's why Bob will win. So this is the solution, b comma c if ls wins and Bob wins. Thank you. Now we will proceed to e questions, upward path. We'll see the upward path question. Here the question is, we are given a 2 rows and n columns. What we have to perform is, we can perform 2 operations. Choose a column and swap the line within it. We can do like swapping these 2 elements of AI and AJ. Suppose A1 is this, wait a second. Okay, suppose A1 has these elements, B1 has these elements, so we can swap between these elements. Okay, and we have to go from 1,1 to 2,n, and we can do two operations, right and down. And what operations we can't do? If AXY means this element is greater than this element, so we can't move that side. Wait a second. Okay, if this element is greater than this element, we can't move that side, and if this element is greater than this element, we can't move this side. Okay, this is the core example. So in this, what we can see that, okay, yes, we can see that we can go to 2 to 2, and we will exchange these two positions. So 2 to 3, so we can go to this, then 4 to 4 we can go in any sides. So we can do 4 5 6 4, but no operations can be done in this. Similarly here we can do 1 2, no operations, because 6 7 8 we can do, but no 9 is there or bigger elements is there, so we cannot move forward here also. But in this case, what we can do, like 1 2 3 4 5, one can be these operations, and that's why. So we can see that we have to move like this. Either we can move like this to this, or we can go, we will find minimum elements, something here and something here, like that. So I am getting some prefix or suffix logic here. Okay, because we have to follow the path, like we can go somewhere here till here, and from here to here, and we can see this these two are equal or greater or equals to anything. So we can think about prefix and suffix logic here. So so we can do, like, suppose 6285 is there, so we will find all the lows, means minimum element here 2 1 2 4 3 and 6 3 8 5 here. So what we will do, we will see that from here, from this point, can we move to 2 and 3? From this, can we move to 6 and means 2 and 3? If yes, we will mark as true. If no, we will mark as false. So in this prefix sums, let's suppose from we are having this for now 0. So for now we are in 1, suppose. So from 1 we can go to 2. Yes, we can go to 2. So I am marking it as 1. From 2 we can go to 4. Yes, we can go to 4. But from 4, can we go to 3 and 5? No, we can't go. So we will return 0 here. Okay. So this prefix become 1 1 0. Similarly, for high 1 to high element of this. So from 1 to 3 we can go. Yes, 1. From 3 to high element 8. Yes, we can go 8. Okay. Like that we can. No, from 2 to 8. Yes, we can go 2 to 8. From 4 to 5 we can go. Yes, we can go. Okay, here 0 is there because 4 to 3 there is no possible way, na? So 0 is there. Okay, it was for low, but now for suffix we will calculate. For suffix, what we will calculate? See, suppose from 5 we can go to 4. No, so we will adjust 0. From 4 we can go to low. Yes, 1. Okay, from 8 can we go to 2, 3 and 2? Yes, we can go 1 1. From 3 can we go to 6? 6. Yes. Can we go to 1? Yes. Can we go to 1? Yes. Can we go to 6? No. So here we got prefix low, prefix high, prefix suffix low, suffix high. Then we will see just if the whole thing is possible or not. So here we can see this part and this part is possible. So our answer will be yes. So here is the code. We have formed all the low element and high element by this. by minimizing and maximizing, then we are preparing what is preload. If yes, if it is greater than or equals to vload and preload, like this what we have done in this part, preload, pre-high, suffix low, suffix high, similar kind of things in here we have done. Okay, similar for pre-high we have seen here. Similarly suffix I have shown you how it will be working. So this loop is for that, suffix low and suffix high. At last we will see for each k, means each mediator. What I was saying, like we were finding this mediator na, so this part is k. So for each we will see that we will see for each k if it is possible. If preload means all the prefix is true, suffix low means all the suffix is true. We will see if k is there where these two are similar or greater or equals to, means these two are true. So that will be our answer. Okay, if both are true, see one case is here is like if both the element of this are same, so we can see this preload and this suffix high or suffix low suffix high is similar, means true, then we can get this condition na. Suppose these two are 2 and we are getting true from prefix low k, or suppose sub prefix high, then we can say that this part is true, and if this is true we can travel down. So from this part we come here, then we will travel down because kk is there. Okay, then if suffix low or high any of the thing is true, then we can move down them, so our answer can be true. Okay, and one case if they are not similar, if we will say they are not similar, so nothing, prefix low should be same, and means they both should be true. Okay, and if any of the two prefix low and k is true, our answer will be yes. This was my solution. Solving the monochrome minimization solution. So what is the question? We are given and wait a second. Okay, n plus m questions, means n plus m points. Okay, so n all the points are in x-axis and m all the points are in y-axis. Okay, and we have to paint n and m plus m balls in red, either in red color or blue color, such that okay, so here the monochromatic number of coloring is defined as the maximum area of triangle formed by any triple point. Suppose this is wait a second, this is x-axis, this is y-axis. So if our red color is there, if red color is this and blue color is this, if any three similar colors are there here, so our area is like this. So this is what is this called as monochromatic maximum area of the triangle. So this is the area of triangle by any triplet. So we have defining here is the defining is that it is the monochromatic number of coloring to the maximum area of a triangle formed by some triple of point that all have the same colors. So if any color of the area is fine, sorry, if there are three dots in this, if there are similar colors in x and y axis, so we can get the area of that by the similar color of three dots, means three points should be similar. We can get the area of these 3 points by the triangle. Okay, and if the area is maximum, then it will be known as the monochromatic number. Okay, and we have to return 2 into a. So what can we do to find this area? Wait. Okay, so if you want to find the area of these 3 points, suppose, what you will do? So here we can see we have to find this area, but we don't have the what is the length and size. If we also have the number, we don't have the exact point where we will be putting, sorry, we will having the exact point where we are putting only. Okay, but we don't have the, but for finding that we don't we have to find angles and that. So better way to find the area of this part is like area area of this triangle minus, so area of this triangle is a, minus area of this triangle. They both are right angle na, so their area will be half into base into height simply. So for bigger part, what will be, so the big triangle equals to half into, suppose this is y, this is x1, this is x2, so y into x2. For smaller triangle it will be half into y into x1. So the area of the remaining triangle will be, area of triangle will be y into x2 minus x1 into half, but we have to find twice into a, so half will be gone, and we have to maximize these operations, y into x2 minus x1 for the area. Okay, but we have, here it is given we can take any points. So how we will be maximizing? And we can see there n into n and m are only 2000. So here we can apply directly brute force. We can see all the points. We can take all the points of A as blue here, or white, or blue or red, and here also we can take any point as blue and red, and just check the brute force. Definitely, because n into m will be more than 4 into 10 to the power 6 only, and that much we can run the loop. So here is my solutions. We will directly sort all the indexes firstly according to length, a and b. Okay, then what we will do, we will first find what is the minimum for xl, xr, rxl. What is the, see, then what we will find, see what is this code is beyond. Here we have sorted all the x points, here we have sorted all the y points. So what we will do, suppose n numbers are for x and m numbers are at y axis. Okay, suppose suppose n numbers are at x axis. Okay, and m numbers are at y-axis. We will say that this is the for now maximum. X naught means XLMN means minimum number. So we will iterate for all I as maximum for now. Okay. Similarly, we can take right as the minimum, XLR minimum, maximum, and we can iterate down. Okay. And right XL minus MN will be, what will be right XL minus MM? This one. It will be the minimum gap between these two points. Okay. See in code what is given. So suppose this is x-axis, this is y-axis, and now this is x-axis. Okay. So what we will do, this will be the mn for y-axis. This will be max of the x-axis, y-axis. This will be the mn for x-axis, and this will be the mx for y-axis. Okay. Clear? So we will iterate all I from here to here to see for which triangle it can be the maximum. So for each I will travel. Here also for each I will traverse. What is the maximum and the minimum? What is the RXL? Is the length. See, if the triangle is like this, so we have to take this. Okay, so this is what it will be. What will be this length is XL max minus XL minimum, or what we can take XL maximum minus XL minimum and XR maximum minus XR minimum, like this. Two values can be done now. If I am taking from this point to this I, then our point area will be this. If I am taking this point to this point, our area will be this. So these are two conditions for this or this, like that. Similarly for y also, if I am taking this area, so this can be done. If I am taking this area to this area, this can be done. So it will be RYR and RYL or R to IL. Just we have to find this maximum for each operations like y. See, so what we can do, so this point, so I can be transferred to this and this, minimum can be this. So here I will write all the cases iteratively for all the variables. See, first XL, what XL will do, multiply with XL R maximum. Okay, this, then RXL will multiply with this, like that. 4 cases can be done. RXL 2 cases, RXR 2 cases, then RYL 2 cases, RYR 2 cases, like that. Similarly here also we will do for V2, what is the maximum triangles. So thank you.